In this video, I'm going to continue to look at the law of indices, and I'm going to see how the law of indices will enable us to take roots of various numbers. Consider this: we have the square root of 4 multiplied by the square root of 4. Now, the square root of 4, as we should know, is equal to 2. So I can rewrite this as equal to 2 times 2, which is clearly equal to 4. Now, the square root of 4 can also be written in an indices form as shown here. We have got 4 raised to the 0.5, where 0.5 is the index or the exponent and 4 is the base. So this also will find us the square root of 4. So this and this are equivalent. So I can go on to show that this can be rewritten as shown here, where we take 4 raised to the 0.5 and multiply that by 4 raised to the 0.5. So this and this is equivalent. Now, if this is equivalent to this here, then we can go on to show that this should also equal 4. Well, let's apply the law of indices. Here you can see the base is 4, it's the same, and here you can see both are raised to the 0.5 and we're multiplying them. Now that means we can write down the base and add the indices together, and I'm going to show that step here. There's 4 raised to the 0.5 plus 0.5, and of course when you add these up you'll get 1. So that equals 4 to the 1. And we will know from previous work in this playlist that any base raised to the power 1 will be that base. Consequently, this will equal 4. So you can see that this gave us 4 and this also gave us 4. So it's correct to say that this and this are equivalent. And we've shown that by knowing that we can add the indices as shown here. Now I'm going to take this and I'm going to rewrite it down here, and we've shown that this is the same as this here, so I'm going to show it here. And now what we can do, we can consider both sides of the equal sign, and we've 2 square roots of 4 here, and we have 4 raised to the power of 0.5 twice on this side of the equal sign. So it's reasonable and obvious that the square root of 4 is equal to this, and this square root of 4 is equal to this. So I can go on to say that the square root of 4 can be written as 4 raised to the 0.5. I will now consider the general case for this relationship here, as you can see coming into view now, that the square root of a is equal to a raised to the 0.5. So if you see this, you know it means the square root of a, and obviously this means the square root of a. So these two are one in the same thing. If this was 4, for example, this would be 4 and they both would give 2. If this was 16, this would be 16 and they both would give 4, because 4 times 4 is obviously 16. So the square root of 16, which is what both of these are showing us, is equal to 4. This here really is the shortcut way of representing the square root of a number a. More fully written out, it should really be like this. This means the square root of a as well, and this 2 in this position, this little 2, tells us we're taking the square root of a. Now we have just shown that the square root of a can be written down like this, a to the 0.5 power, but we can also write it down like this, a to the 1/2, because obviously 1/2 is 0.5. So this really is the decimal way of writing it down, and here you can see I'm writing the power down as a fraction. Now consider the following. Here you can see I'm taking the square root of a, and I've used the technique of putting the little 2 here. Now, when you see this, what we're saying is that we're taking the root of a, and the root we're taking is governed by this 2. And the 2 appears here in this fraction, which is showing a raised to the power of 1/2. So the position of this 2, when we decide to write out the square root as a power, the 2 goes here underneath the 1. In other words, the 2 will divide into the 1. Now this and this mean the same thing. Now the general case for this is coming into view now. You can see that the rth root of a is equal to a raised to the 1 divided by that r. Now, if this r was a 2, what we would have here is a 2. And this would be a to the 1/2. However, if we were going to take the cubed root of a, this r here would be 3, and this r here would therefore be 3. So a to the 1/3 would be equivalent to the cubed root of a. So if there's a 3 here, the 3 appears here. And when it was the square root, this was 2, and the 2 appeared here. Now this is useful for when we decide we want to take various roots of numbers within Python. Let's consider this, which is the general case for finding various roots of a number. And I'm going to look at finding the square root of 4, and the example for that is shown here. This means find the square root of 4, and we know that that is equivalent to 4 raised to the half, which will result in the value of 2. Now let's look at a Python program that we can use to find the square root of 4. Now there are a number of ways to find square roots in Python, but in the program I'm going to show you, I am going to be effectively implementing this here. So let's now have a look at the Python program. So here's the Python program coming into view, and if you look at this line, you can see we're printing this calculation here. And if you look at this, you can see it's a raised to the power 1 divided by r. So this is representing this, which is a raised to the power 1 divided by r. And in this program, I'm setting this value of a, as you can see here, to 4. And I'm setting this value of r, as you can see here, to 2. So when I execute this program, I am expecting it to give us the result of 2, because this should be finding the square root of 4. So let's look at the runtime, and you can see it indeed gives us 2. And you will note that it's a float, but it is the value of 2 nevertheless. Here you can see the general case again, and on this occasion I'm going to be asking us to find the square root of 16, which you can see here can also be found by 16 raised to the power 1/2, and we know the square root of 16 is equal to 4. Now if we look to the Python program, it's going to be almost identical to the one we've just seen, except I'm going to be choosing a different value for the a. So let's have a look at that computer program coming into view now. And there you can see I'm letting a equal 16, r is still equal to 2, and this is the same calculation. So if I run the program, what we can see we get is 4, showing us that this formula here, which is what I'm effectively placing here, allows us to find the square root of a. And what we need to know is r, which we can take from here, telling us that it is going to be the square root in this case. We've just dealt with finding the square root. Let's now have a go at looking at how we can find the cube root of a number. And before I do that, let's just remind you of what a cube root is. Here you can see I've got 3 raised to the power 3. Now that means I write down the 3 times, as you can see, and multiply them together. And when you multiply 3 by 3 by 3, you will get 27. Now the cube root of 27 is where we're looking for a number that when that number is multiplied together, as you can see here, we get the 27. Now we should realize that it's going to be 3. The cube root of 27 is 3. Now in mathematics we can write this down as shown here. There's 27, and you can see it has the root symbol and the little 3 here. Now this means the cube root of 27, which is equal to 3. Let's just quickly look at another example before I move on to look at how we can find the cube root in Python. And here you can see 5 raised to the power 3 is the 5 written down 3 times and multiplied together to give us 125. Now the cube root of 125 therefore is 5. Now that can be written down as shown here. There's the 125 inside the root symbol, and here we've got the little 3. So this is saying what's the cube root of 125, and we can see that it equals 5. Try that on your calculator if you so wish. Let's return to this general case here, and let's use this to help us find the cubed root of a number. And the number I'm going to choose is one we've already seen in this video, and that's the cube root of 27, which you can see written down here. here. This is the cube root of 27. Now this 3 is going to be the value of r, and this 27 is the value of a. So you can see that I've wrote down the 27 here, and this 1/3 is there because of this, and of course the r picks up this 3 which it placed here. So 27 to the power of 1/3 equals 3. Let's confirm this with a Python program that's coming into view now. And what you can see, this line is going to be printing this calculation. And clearly this calculation is implementing this here. This is a raised to the power of 1 divided by r. So if I now consider this, you can see a is 27, and that's what I've set here. A is equal to 27. And r, if you look at this, is 3, and that's what I've put here. R is assigned 3. So this is 27 raised to this power, which is the 1 divided by 3, which means we're raising a to the power of 1/3. So if I run this program, it should show us that the result is 3. This value here. So let's run the program and see what we get. And you can see we get 3, albeit it's in its float format, 3.0, but that is still the value of 3. Let's just quickly look at another example which doesn't find the square or the cube root, just to show how this formula can work for many different roots of numbers. Here you can see I'm raising 4 to the power of 5, which means I write down the 4 5 times, multiply them together, and I will get 1024. Now if I wanted to find the 5th root of 1024, I should get the 4 back. So I can show the 5th root of 1024 in mathematics as shown here. There's the 1024 inside the root sign, and this 5 here tells me that we're taking the 5th root of 1024, which is equal to 4. Let's just make sure we can remember the general case, which I'm showing coming into view here. You can see that this general case means that the r will be picking up this value of 5, and this a will be picking up this value here. So if I look to a Python program now, as shown here, you can see I've made a equal to 1024, and I've made the r equal to the 5. Now if this program works, it should give us the value of 4 that we showed on this line. So let's have a look and see what we get. And you can see indeed we do get 4. So we can see that this here is going to be very useful when we want to find various roots of numbers. We can see that this is the calculation we use in the program, and this is the root that we wish to find of the a. So if this was 6, we'll be finding the 6th root of a. If this was 2, we'd be finding the square root of a. If it was 3, we will be finding the cube root of a, and so on. Now the key point of this video is that if you use this general case that's come into view now and use this formula, it will enable you to find the roots of numbers. And in this video we've looked at how this will enable us to find the square root, the cube root, and the 5th root. And of course you could find many other roots of the number a using this formula. Bear in mind there are other ways to find roots of numbers, but this example here is one that I've shown you, which can be very useful because you don't have to import any modules to quickly find the cube root, for example. You can use it with what's available within the language without the need for any imports. Check out the supporting website for these videos. In addition, why not follow me on Twitter, as I issue a tweet every time I upload a new video.